Now we're going to find the distance between two parallel lines. So here are our two lines. These are our equations of the lines. We recognize this one. This is in the form y equals mx plus b. It's our favorite form of a line, where 2/3 is m, it's our slope, and -3 is our y-intercept. Alright, so we want to find the distance between these two lines, so first thing we need to do is graph them. So we're going to graph this one first because it's the easiest. So we're going to go down to -3 and put a dot at our y-intercept and then apply the slope. So we're going to go up 2 and over 3, put another dot. So when we graph this, it's going to look something like this. And this is the equation y equals 2/3 x minus 3. Alright, now let's graph this one. This one's not going to be quite as easy because it's not in our favorite form, but we need to solve for y so we can graph it. So I'm going to write it down here, 2x minus 3y equal to 6, and I'm going to solve for y. So, first thing I do is I take 2x to the other side. So let's subtract 2x from both sides. This goes out. -3y is equal to -2x plus 6. Now I want to get y by itself, so we're going to divide everything by -3. This goes out. Y is equal to, I have -2x divided by -3. Two negatives make a positive, so 2/3 x. 6 divided by -3 is a -6/3, which is our -2. And this is the equation of my next line. So I go down to the y-intercept -2, and I put a dot, and I apply the slope. It's a rise of 2 and a run of 3. So when I graph this, it'll look like this. So this is the equation, y equals 2/3 x minus 2. Not plus, but minus 2. Now I can tell that they're parallel because they have the same slope. And I want to find the distance between them. So we're going to again follow our little rhyming device. We need 3 pieces of information, 2 equations of lines, 1 point of intersection, go back, plug it in. That's 3 pieces of information, 2 equations of lines, 1 point of intersection, go back, plug it in. Alright, now our 3 pieces of information are our 2 points. And then we're going to use the distance formula to figure out what the distance is between these 2 points. And then we're going to have 2 equations of lines, and 1 point of intersection is what we'll get, and we'll go back and plug it in here. Alright, so let's start at the beginning. Our 2 pieces of information are 2 points. So if we look back here and we remember about distance, you can take the distance between any 2 parallel lines basically anywhere. But if we notice, then the wisest place to choose is right here at the y-intercept. So we're going to draw our perpendicular line segment right here at the y-intercept. And this orange distance is the distance that I want to find. And as a matter of fact, since we've chosen wisely, we already know what this point is. It's 0, -2. So one of our points is 0, -2. And this is the other point that we want, and it's the intersection between the orange line and the purple line. And the purple line, the equation for the purple line is this one, y equals 2/3 x minus 3. So y equals 2/3 x minus 3 is the equation of this line. And I want the equation of the orange line. That's going to be my second one. And I think I can use y equals mx plus b. Because I know the y-intercept, because we chose wisely, we use the y-intercept from the top equation, so I know my y-intercept is -2. Plus, bring down my x, and now my slope. The slope of my parallel lines are 2/3, and since this orange line is perpendicular, my perpendicular slope is going to be the negative inverse. So if this one's positive, a negative inverse would be negative, and if I invert 2/3, I get 3/2. So my perpendicular slope is a -3/2. So we plug this in, and this is my other equation. So I've got my 2 equations now. y equals 2/3 x minus 3, and y equals negative 3/2 x minus 2. So all I have to do is put these two equations in on my calculator, and it'll tell me what the point of intersection is. So I'm going to turn on my calculator, and I've actually already got it on there. So I've got 2/3 x minus 3 and negative 3/2 x minus 2. And I want the calculator to calculate the intersection. So I press second and calculate, 5 for the intersection. Since these are linear equations, we don't have curves, so enter, enter, enter. And my intersection is at 0.46 and negative 2.70. So I write them down. This is at 0.46 and negative 2.7. Alright, so all I have to do is transfer it up here, 0.46 and negative 2.7. Okay. Alright, now most of the way there. All I have to do now is plug it into my distance formula. So let's remind ourselves what the distance formula is. It is x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Square root of all of that. So we plug it in. What we want to do first is label our points. So we can label 1 x1 y1 and then x2 y2 and just plug it in. So x sub 2 is 0.46 minus x sub 1, which is 0, squared, plus y sub 2, which is negative 2.7, minus y sub 1, which is negative 2, squared. Now, in order to save time, let's do this on our calculator. So we put our square root, second square root, open parentheses, 0.46 minus, well, minus 0, so let's just skip that, and square it. So 0.46 squared plus, open parentheses, negative 2.7 minus a negative, minus a negative 2 squared, and my answer is 0.84. Now just to check this, we want to make sure, because 0.84 is not very much. As a matter of fact, it's under 1 unit. So if I come over here and I measure exactly what 1 unit is, just with a piece of paper, I can tell that that is actually underneath 1 unit. So this is a pretty good guess. So our distance is 0.84.